Fluid coding and AI. A repo agent can look simple until it has to touch a real workspace, ask for approval, survive an interruption, and explain what it changed. Today, we are building the same agent twice, first as a minimal custom loop, then as an Agents SDK Sandbox agent. The question is not which one feels clever. The question is which harness you want to own. The useful comparison is infrastructure, not intelligence. A tiny loop can prove the idea fast. It can send instructions, expose a few tools, run a verification command, and stop when the model returns a final answer. But production-shaped repo work adds boring requirements: workspace boundaries, patch review, shell approvals, trace logs, resume state, output collection. This episode asks whether the SDK packages enough of that recurring harness work to stop rebuilding it project by project. The timing matters because current models are strong enough that the harness becomes visible. OpenAI reports GPT 5.5 at 82.7% on Terminal Bench 2.0, 58.6% on SWE Bench Pro Public, and 78.7% on OS World Verified. Those numbers do not prove the SDK is better than a custom loop. They are model evaluations, not runtime evaluations. But they do make a practical point: if models can operate in terminals, browsers, and repos, then execution control becomes a real product decision. The custom loop starts beautifully small. Give the model a repo task and a short system message. Add a file reader, a shell runner, and a patch tool. Keep a transcript. Let the model inspect files, run tests, edit code, and return a summary. For teaching, this is excellent. Every moving part is visible. There is no framework magic. You can see the agent loop as a sequence: think, call tool, observe, decide, and eventually stop. Then the real requirements arrive. You need to decide which shell commands require approval. You need logs that explain what happened after a failure. You need to resume after a crash, a rate limit, or a human approval delay. You need to prevent the agent from wandering outside the intended repo. None of that is impossible in a custom loop. The issue is that each feature lands as another wrapper, another state file, another policy check, and another edge case. The sandbox version starts from a different premise. A repo agent needs a workspace contract. In the Agents SDK docs, a manifest defines the fresh sandbox workspace. It can include files, directories, Git repos, mounts, environment variables, users, groups, permissions, and controlled path grants. That changes the shape of the code. Instead of hoping the model respects a path mentioned in prose, the application declares what exists, what can be written, and where output should land. The next piece is how a run gets its sandbox. The SDK describes sandbox run config as the decision point. A run can reuse a live session, resume stored session state, resume from run state, or create a fresh session from the manifest. For local development, OpenAI recommends Unix Local Sandbox Client first. Docker Sandbox Client is the next step when you want container isolation or image parity. Hosted providers come later when managed execution matters more than local control. The most important architecture point is the split. The outer SDK runtime owns approvals, tracing, handoffs, and resume bookkeeping. The sandbox session owns command execution, file changes, and environment isolation. That separation is why this is not just a nicer function call. It gives the application a place to enforce policy around actions, while the workspace stays contained inside a controlled execution environment. The model still has to solve the task. The harness decides how much damage a bad step can do. Approvals are where the custom loop usually gets messy. A prompt that says "ask before dangerous commands" is not the same thing as a runtime approval gate. The SDK human in the loop flow can pause a run until a person approves or rejects sensitive tool calls. The docs describe approval rules for function tools, agents exposed as tools, shell tools, apply patch tools, and MCP servers. For repo agents, that matters because the approval sits where the action executes. Observability is the second place the SDK earns attention. Agents SDK tracing is enabled by default. The docs say it records model generations, tool calls, handoffs, guardrails, and custom events, and it can export to OpenAI traces or custom processors. Run results also expose final output, new items, raw responses, interruptions, and serializable state. For a repo agent, that means the final answer is not the only artifact. You can inspect what the agent saw, what it tried, and why it stopped. Durability is where demos become jobs. The SDK docs describe sessions for conversation history, run state for serializing and resuming runs, and snapshots that can restore saved workspace contents at sandbox start and persist workspace state at cleanup. That does not remove every failure mode. Dependencies can still break. Tests can still be flaky. A hosted provider can still behave differently from local development. But resume paths and workspace snapshots are the difference between try again from scratch and continue the job with evidence. The SDK does not make repo agents automatically safe or production ready. Sandbox agents are still labeled beta in the docs, so API churn belongs in the decision. Tracing can include sensitive model and tool inputs or outputs unless configured carefully, and zero data retention organizations do not have OpenAI tracing available. Sandboxing also is not a full security policy by itself. Mounted paths, credentials, network access, provider behavior, and path grants still need application-level rules. The SDK gives you better control points. You still own the policy. The custom loop still has a job. Use it when you are learning the mental model, proving a narrow workflow, or keeping the assistant intentionally small. If all you need is one model call, one tool, and one final answer, the SDK concepts can be more machinery than value. The custom loop is also easier to make provider agnostic. When requirements are small and the blast radius is low, owning the whole abstraction can be the right trade. The honest test is to give both agents the same repo task. Use one repository snapshot, one issue prompt, one verification command, and one required output report. Then judge the harness, not the demo feeling. Did test pass? Were edits scoped? Did risky commands require approval? Could the run resume after interruption? Can you inspect the file changes, the tool calls, and the reason it stopped? That test will not prove every future case, but it will expose whether your real bottleneck is agent logic or agent infrastructure. Here is the conditional verdict. Build the custom loop first if the goal is understanding, prototyping, or keeping full control over a tiny workflow. Reach for the agent's SDK Sandbox when the roadmap already includes real repos, explicit workspace setup, shell and patch approvals, traces, snapshots, resume support, and a path from local development to Docker or hosted execution. The SDK is not making the model smarter. It is competing with the harness you were about to build around the model. For repo agents, that is the more interesting comparison. If this helped you separate the agent loop from the agent harness, like the video and subscribe to Fluid Coding and AI. The next time a repo agent demo looks easy, check what happens when it needs approvals, traces, state, and a real workspace boundary.